Hey everyone. Recently, our team has been exploring and building MCP servers for various use cases. Now that some of our MCP servers have evolved, we have come across a critical challenge. How do you test MCP server effectively without breaking existing functionality? How do you make sure that whenever you make some change to one of your MCP tools, you have not regressed anything? We discovered the MCP inspector tool and decided to explore it by testing it with Postman's remote MCP server. Let me walk you through our experience and the interesting challenges we uncovered. Here is the MCP inspector. I'm connecting to Postman's remote MCP server using streamable HTTP transport with proper authentication. Let's connect to the server. Perfect. Now let's list the available tools. Awesome. We can see all the tools Postman's MCP server exposes. Let's maybe test one of the tools. I'll pick create workspace. Okay. So here is the form, which are basically the inputs required by this particular tool. So let me put in some name. I'm calling it dummy. Let me select personal as the type. Some description can be anything. And about also dummy. And let me run this tool. Okay. We got a success. So that's great. Now I want to make sure that other types of workspaces also get created with this tool. There is no failure over there. So let me maybe select public this time. Let me run this. Awesome. This is also working fine. We got a success. Let me select team maybe once. Let's run this. Oh, great. That is also working. So this is great. All three workspace types work perfectly. But here's where we hit our first challenge. Every time I modify this particular tool, like I change the tool's implementation, I'll need to manually test these scenarios again. And I think that's tedious and error prone. Let's maybe try some other tool. Let me scroll down and maybe pick this particular tool, update mock. Okay, I need to enter the mock ID. I'll enter dummy as the mock ID. Mock is a JSON object. Okay, so I'm not sure what fields need to go in here. So maybe let's quickly have a look at update mocks input schema. So let me go to that. So let's see, where is update mock. Here it is. So let me open the input schema, properties, mock. Okay, so these are the properties I can pass: name, environment, description, private version tag, config. So these are all optional. So maybe I'll just pass name. Mhm. Okay, with this, let's run the tool. Okay, we are getting an error. What does it say? Param collection message is parameter missing in the request. Okay. So basically, this is saying that collection is a required parameter which is missing. But interestingly, we didn't see any collection parameter over here. Maybe let me validate that by passing a collection field over here and see if this error goes away. Run tool. Oh, okay. I am getting a different error now. So collection was a required parameter, but as per the schema, we didn't get any clue that it is required. So this basically reveals our second major challenge. The schemas and the implementations can be out of sync. We will need to do comprehensive testing to catch these issues. We will need to test with different input combinations to catch such issues. That is the second major challenge that we faced. So we identified two critical problems. The first being manual testing for every change is unsustainable. And the second being schema mismatches and edge cases, they require extensive input combinations. And those are impractical to test manually. When we looked around for solutions for the challenges, we didn't really find anything for MCP servers. That's when we realize Specmatic has already solved such problems for other protocols and other specifications like OpenAPI, Sync API, etc. That's when we realized we had to take matters into our own hands. The solution that we built is basically a CLI tool that comes packaged as a subcommand of the Specmatic parent command. Instead of manual testing through a GUI, you can now run comprehensive automated tests against your MCP servers. Let me demonstrate exactly how it works and how it solves both problems we identified. Let's run comprehensive tests using the same Postman MCP server we tested earlier. And I'll use the dictionary argument to provide realistic test data. So let's run this and see what happens. Okay, we can see a bunch of logs over here and the test has started running. What's happening here is Specmatic has first sent an initialization request to the remote MCP server to initialize a connection with it. Then if we scroll down, Specmatic has fetched a bunch of tools by making the tools list call. The response of this tools list call contains the input-output schema for each tool. Specmatic has fetched these input-output schemas and made use of them to basically generate tests for each tool. And those tests are getting executed over here. Perfect. The test run has already completed. And if you see here, this is our console report where we have the tool name, whether that particular tool has passed or failed, and we get a success percentage. Over 35 tools have been tested as part of this test run. And if we scroll to the very bottom, we get a summary as well where we see the total number of tests that have run, which tests have passed, how many tests have failed, and the overall success rate. A JSON test report also gets saved as part of this particular test run. Okay, now let's have a look at one of the tests. Okay, let me scroll up. This is a test for the update workspace tool. And you can see these are the arguments which are being passed to this particular tool call. These arguments are passed by Specmatic Auto-Test automatically. And since this tool call returns a successful response, the test is marked as passed. Similarly, other tools are invoked with their respective request arguments and their response is verified to determine whether it is a success or a failure. If it is a successful response, the output is also verified against the output schema. Thus, Specmatic Auto-Test ensures comprehensive coverage of the MCP tools. Now, let's see how MCP Auto-Test solves our first challenge, that is automating tests that we had to run manually in an MCP inspector. Remember the create workspace tool where we manually tested personal, public, and team types? Let's see MCP Auto-Test handle this automatically. So you can see I'm using a filter tools argument and passing the create workspace tool over here. And I have also enabled resiliency tests by using this particular argument. This particular flag basically enables comprehensive input combinations for the same tool. So let me run this. Awesome. The test run has completed. And you can see the massive number of tests that have run just for a single tool. This is due to the enabled resiliency test flag. It has passed different sorts of input combinations to the same tool and tested whether it passes with those sorts of input combinations or not. Let's just have a look at some of the tests. If we look at the first test, this is for the tool create workspace. The mutation done here by Specmatic is workspace.type selected personal from enum. If we look at the arguments, we can see the type that is been selected as personal. And since we got a successful response back, the test has passed. If I scroll down and if we look at the third test, again, this is for the same tool create workspace, but the type that's been selected over here this time is public. We can check in the arguments, the type is indeed public. Then in the next test, the type has been selected as team and so on. Thus, MCP Auto-Test has automatically tested different input values for the type field, which are personal, public, team, etc. This is exactly what we were doing manually before, but now it's completely automated. Now let's see how Specmatic addresses the second challenge that we face, which is catching edge cases like schema mismatches. Remember the update mock tool where the schema didn't match the implementation. Let's run the test for it using Specmatic. Perfect. We can see it is failing, and that too with the same reason, which is parameter is missing in the request. Now imagine the developer to run this locally or as part of CA. This issue would have never leaked to production. This is true shift left for MCP server development. MCP Auto-Test runs tests against all tools with different input combinations if resiliency is enabled. This provides truly comprehensive testing coverage. So here's what MCP Auto-Test delivers: automatic test generation using your tool schemas, realistic test data through customizable dictionaries, comprehensive input combinations via resiliency testing, edge case detection including schema mismatches, and most importantly, regression prevention through repeatable test suites. This completely solves both challenges we faced with MCP Inspector, which were no more manual testing. You can run comprehensive test suites with a single command, and no more missed edge cases due to automatic input combinations which catch issues you would never test manually. MCP Auto-Test gives you the ability to iteratively develop and test your MCP servers without the tedious manual effort, ensuring your tools work correctly as your implementation evolves. Also, if you haven't figured it yet, this tool is open source. So, we are inviting the community to join us and contribute to make this tool better.